Hello, welcome again to Block 2, Use of Algebraic Notation, Lesson 10. I'll share my screen. Okay, so in your previous lesson, you learned how to find the function machines when you were given the expressions input and output. In today's lesson, you're going to learn some really good foundations in understanding the principles of algebra by substituting into two-step expressions. However, before we start, I would like you to do the retrieval practice. You can pause the video and do the retrieval practice in 3 minutes. You can take longer, you can take work according to your pace. Assuming you have paused the video and you've worked through these problems, let's discuss them. Here are the answers. So here you're asked, which bar model represents 2w plus 3? Remember, the bar in the bar model, we add the bars. So a proper way to represent 2w plus 3 will be 2 bars each w and another bar that is 3. Here, you must remember, I'm sure you learnt it in SATs or earlier on in maths, that you need to do the multiplication first. Okay? So this becomes 4 plus 18, which is 22. Don't forget this. Beat maths. We're going to come across this at some point, but I think I should mention it now. Next, you were asked to substitute b equal to 3 into the expressions. So this was from your previous lesson. You should not forget substituting, how to substitute into single expressions. Okay, so here we simply replace b with 3, but remembering that 12b means 12 times b. So this is 12 times 3. Here is simply adding b to 12. b is 3, so you get 15. Here you're dividing 12 by b, which is 3, and then your answer is 4. Here you're subtracting 3 from b. B from 12, which is 12 minus 3, which will give you 9. Okay, let's move on. Now, if I give you this expression, 2w plus 3, to substitute 2 into the expression, well, you must remember that if we were to represent this as a bar model, this would look like this. Why? Because you have W and W with 3. If you add the bars and you replace W with 2, because you've been told to make W 2, your answer becomes this. So actually, you can substitute 2. You can substitute 2 to replace W, so which gives you 2 times 2 plus 3. Now, what about this one? This one, you must remember that when we were working using the bar model, something like this means you have 2 lots of W add 3. So it looks like this. So if you replace 2, if you replace W with 2, you have this. And so when you add them, When you actually work it out, it looks like this. So 2 times 2 plus 3, because W is 2. Your answer is 10. Okay? If we think about it as a function machine, what has actually happened here? Remember, in our previous lesson, I did say it's really important you know how to read expressions. To read means you know what is really going on with the expressions. So here, we're multiplying by 2, whatever we put in. So if we put in W, that's what we'll get. Okay? So if we put in W, that's what we'll get. So we multiply W by 2 before we add 3. Here, we put in W, we'll add 3 first before we multiply by 2. Okay? So really, when we work this out, by replacing the letters with the numbers, we get the same result. What about this one? This one means if x is 50 and we've been told to work out the value of this expression, we need to replace the x with 50. Now, if you think about it as a function machine, your input, let's say we put our input x, we're dividing by 2 first before we subtract 8. And that gives us this expression. So it's important you really understand how to read the expressions to know what's really going on. That makes substitution super easy. So when you put your number, you're very sure that you get the correct result. What about this one? This one, if you think about it as a function machine, we need to subtract 8 first before we divide by 2. So here it is. Okay. So we know that because we can read the expression correctly, then our substitution would be right. So if we put 50, we have to subtract 8 first before we divide by 2. And that gives us 21. Here is this one. Here is another example. If we have k equal to 9, by now we know how it really works. So we may not really be using the function machine. Okay, we just know we'll go straight into doing our substitution. So 6k means 6 times whatever k is. And k in this instance at this moment is 9. So we say 6 times 9 minus 11. Or subtract 11, and that gives us 48. What about this one? Again, we can just do our substitution straight away. This time k is 9. So we do 23 subtract 9 divided by 4, and our answer is 14 over 4, which is 3.5. Okay, what we've learned so far is that once you understand the fundamental basic principles, the basic principles of algebra, then you can go straight to your substitution. You do not need to be using the function machines, but it helps to have the function machine, and the bar model helps you to be thinking about what's really going on so that you can do your substitution correctly. Okay, I would like you to pause the video and do these questions for 3 minutes. Assuming you've paused the video and you've done the questions, I'm sure you're doing very well. Well done. Here are the answers. Let's discuss them. So answer to question 1, you're asked to substitute y equal to 6 into each of the expressions. Now, there are bar models on the side to help you really understand how to read the expressions. So this one means 3 lots of y add 2. So if we replace these y's, this y in the boxes with the number 6, because that's what substitute means, you have your answer as 20. And it's the same here. Okay, so this one means 3 lots of y add 2. You can see the bar model there. So if we replace the y with 6, it means we have to add 6 to 2 first, which will give us 8 before we have 3 lots of that. And then here is the other one. Okay, so I'm sure you got all of them right, and you should be celebrating. Give yourself a pat on the back. Well done. Okay, question 2. Here is the answer. Jack is substituting g is equal to 3 into these expressions. Here, Jack says, I will get the same answer for both, as I just need to multiply g by 4 and add on 5. Draw a function machine for each expression to show why Jack is incorrect. Of course, Jack is incorrect, because if we draw a function machine, we can see that for this one, okay, whatever we put in, we need to multiply by 4 first, and then we add 5. You can see your answer is different. Whereas this one, you need to add 5 to g first before you multiply by 4. Okay, here is question 3. I would like you to pause the video and do question 3 in 3 minutes. Okay, assuming you've paused the video and you have really thought about what you've learned and you've worked through the questions, here are the answers. Let's discuss them. So these ones we can just do as substitution straight away. You already know how to do algebraic substitution, yeah? So here you've been asked to make z 6. So this will mean 3 times 6 plus 7. This will mean 2 times 6 minus 5. This will mean 10 times 6 plus 6.3. Okay. Let's just go to these ones, which may look a little bit challenging. This will be 20 minus 2 times whatever z is. In this instance is 6. Yeah. So 20 minus 2 times 6. This will be 3 times 6 plus 7. So you need to do 6 plus 7 first before you multiply whatever you get by 3. This one is the same. You need to do 6 minus 5 first before you multiply by whatever is outside the bracket. It's the same here. This one, you need to do 6 minus 1 first before you divide by 5. Here you need to do 6 divided by 3 first before you add 2. And then here you do the same. 3 add 6 divided by 2. Okay. What about if we have something like this? Remember, in our early lessons, we talked about what squaring means. So squaring means you're multiplying the number by itself. So b squared, or b to the power 2, is b times b. What about this one? This means we have b to the power 2 and then we multiply by 4. Okay? And then this one means you multiply 4 by b first before you square everything. So this means 4, yeah, this is 4 times b, so that one. And then this is 4b times 4b. Okay, so it looks like this. So if we were actually given, let's say we're told that b is 2, this one will be, okay, so if we were told b is 2, this one will simply be, we can write this as 2 squared, because b is 2, and this is 2 times 2, which is 4. If we do the same, this will be 4, this looks like this, 4 times 2 squared. Okay, or another way of thinking about it is 4 times 4, which is 16. This one will be, because we're told that b is 2, right? So I have said, let's say if we're looking at this, b is 2, then this would look like this. 4 times 2, right? and then you square it. Okay? So it's really important that you understand how to work with things like this, with terms like this, algebraic terms that look like this. Okay, let's move on. So at this stage, what you've learned is that you can work with squaring. You understand how squaring works. So I would like you to have a go at question 4. So pause the video for 2 minutes or 3 minutes and do question 4. Okay, assuming you have paused the video and you've worked through it, you've really thought about it, let's look at the questions, the answers up to question 4, and then let's discuss it. Question 4A and B. Question 4A, you ask, Dora has evaluated the expressions 4x squared or 4x to the power 2 when x is 3. Dora has made a mistake. What calculation should Dora have completed first? Of course, Dora should have done the squaring first before multiplying by 4. Okay? And that would give Dora a different result. Okay? Then for B, what would the expression need for the answer to be 144? For the answer to be 144, we need to have 12. Okay? We need to have 12 squared, which means we need to have the expression looking like this. Okay? All right. For C, here are the answers. Okay? We're substituting x equal to 5. So here we square 5 first before we times by 2. 5 squared is 25. 2 times 25 is 50. And then this, you can see it's different. Okay? You multiply 2 by 5 first before you square it. Okay? And those are the other answers. Now, let's talk about use of calculator. Whitney is using a calculator to substitute y equals 513 into the expression 14y minus 74.4. Here is what Whitney does. Okay? She did the calculation in 2 stages. Okay? First, she did 14 times 513, wrote the answer on the side. Okay? And then before she subtracted 74.7. Of course, Whitney is correct, but she could have done the calculation all in one go because the calculator can do this order of operation. The calculator can do the order of operation properly. So an efficient method would have been to just put the whole calculation in the calculator and press the equal sign. Okay? However, for this one, the calculator, okay, if you were to do this, if Dexter were to do this, Dexter won't be correct because the calculator does not understand the order of operation to do this. So, a proper way to do it is to use brackets. Okay? So in your calculator, you would see the sign to input. You press the bracket sign first, type 10.2 minus, then 5.5, and then you press the other bracket sign to close it before you do divide by 8. Now, what I need to advise is this. Students sometimes do not really know, okay, when do I use bracket or not? So my advice is just use brackets all the time so that you know the order of operation, you know how substitution works. So just use brackets to make sure you execute your correct order of operation all the time if you're not sure when to use it. And so that should be the correct answer Dexter would have got. Now, how can we use a calculator to work out squares and powers? Okay, we're talking about use of calculator now. To work out squares and powers, you'll have this button on your calculator. This is to square a number. Now, if you want to square 5, you type 5, you press this button, you press the equal sign, and that would work. It will calculate 5 squared. So if you were given a question like this to say, work out 5 squared using a calculator, or let's say it's a very large number, you could do it that way. Okay? If you're asked to calculate higher powers, let's say, for example, we want to work out 5 to the power 6. You say, wow, how do I do that? There is a button that looks like this in your calculator. So some calculators look like this or like this. So to calculate higher powers of a number, for example, 7, we can type 7. Let's say we want to work out 7 to the power 5. We type 7, we press this key, okay, or for some calculators, this key, you type 5, which is the power, and then this will work out 7 to the power 5. Okay, so you press 7, you press this key, 5, you type your equal, you press your equal key, and then that calculates it. Okay, so far we have learned about using powers. So you know how squaring works by now. So you should be able to use that concept to answer the questions that will be coming up. And you have also learned how to use calculator to work out powers or squaring, okay, using the correct keys in your calculator. Now, I would like you to pause the video and answer question 5 in 3 minutes. So, assuming you've paused the video and you've really thought about this, you've worked through the questions, here are the answers. Okay. So, this time you're giving, two different numbers to use. So, K is 16 and M is 0.5. Okay, we follow the same rule. So we here, for example, this one, you substitute K to be 16 minus 0.5. Okay, so it's the same rule. You simply just replace the letters with the numbers. Okay, all right, let's move on. You can pause the video and have a go at question 6. You can use 2 minutes. Assuming you've paused the video and you've worked through this, here are the answers. So question 6, A and B. Here you ask, substitute different values of M into each of these expressions. Explain why for any value of M, the second and third expressions will always be equal. Okay, to always be equal, because if you remember from one of our lessons, this is like this. If you remember, I did say we'll come across this at some point. So this is like saying 5 times M. Okay, whatever is outside is multiplying what's inside plus 5. So this is 5M plus 5. Or you can use the bar model to think about it. You have M bar, and then you have the bar for 1. And then you have 5 lots of that. So you have M bar, bar for 1, M bar, bar for 1, okay, M bar, bar for 1, M bar, and bar for 1. So remember, for our bar model, we add our bars. So we have m plus m plus m plus m plus m is 5m. And then 1 plus 1 plus 1 plus 1 plus 1 is 5. Okay? Now here you're told, explain why for any value of m, the second expression will always be 4 more than the first. Okay? So this is the second expression and this is the first. Okay? So why will it always be 4 more? Now this is 5m plus 5. Okay? But this is 5m plus 1 plus 4. Okay? So it will always be 4 more than the first. Why? Because this is just 5m plus 1. Yeah? Why? This is 5 lots of m plus 1. So when you actually work it out, this is 5m plus 1, which we can rewrite. If we were to rewrite this, we can say, oh well, this is 5m plus 1 plus 4. So you can see this one is this one here, and it's 4 more than that one. Yeah, this one is 4 more than this one. Yeah, okay. Okay, that brings us to the end of our lesson. So what have we learned so far in this lesson? In this lesson, we have learned using the principles of algebra to do substitution into two-step expressions. Okay, by following all those principles and by also knowing how to use calculators to work properly, you have built some really solid foundations that will serve you even right through to year 11. Okay, until next time, take care and bye bye.